When you solve trig equations, you have the same goal as when you solve regular equations, to isolate the variable. In this case, it's theta. The difference with trig equations, though, is you should kind of take it in two parts. Your first goal should be to isolate sine of theta. Then we'll work on just theta. In order to get sine of theta alone, we should first subtract 1. We have radical 2 times the sine of theta equals negative 1, and then divide both sides by radical 2. We're left with sine theta equals negative 1 over the square root of 2. If you want, you can rationalize this and make it negative radical 2 over 2. Now, this negative sign plays a huge part in determining what our theta is. We need to figure out which angle has a sine of negative radical 2 over 2. If you're thinking that there should be two answers, you're right. I know two places where sine is negative, in quadrant 3 and also in quadrant 4. So there's going to be two answers for theta. In quadrant 3, rad 2 over 2 represents the sine of 45. So that means the 45-degree reference angle of quadrant 3 and the 45-degree reference angle in quadrant 4 are the answers. All we have to do is figure out what 180 plus 45 is, and also 360 minus 45. 225 and 315 are the angles then that solve this equation. In the beginning, I'll give you hints about how many answers you should be looking for. Here, we found our two answers, 225 and 315. Now, there's always ways to check equations. You guys know that to check a value for theta, all we would do is plug it back in. Another way to check is graphically. If you look at this graph, we can see that the zeros of this function, when this function is equal to 0, occur here and here at 225 and 315. So that makes sense. Algebraically, we can check both of these answers too. We can start with the original, radical 2 times sine of theta plus 1 equals 0. And for each of these, we can plug these numbers in. I recommend making sure your calculator is in degree mode, and then you can just type this whole thing in. The square root of 2 times the sine of 225 plus 1 equals 0, which is good. Let's check 315. Again, let's type this entire thing into the calculator. And again, we get 0. That means both of our answers checked. We have successfully found two answers to this equation. Pause the video and try the example below.
Good night, Mr. Goldblatt.
Good night.
Now, trig equations aren't always going to be that easy. Sometimes we'll see quadratic trig equations. You'll solve a quadratic trig equation the same way you'll solve a normal quadratic. When you look at 2x squared minus 3x plus 1 equals 0, immediately you should want to factor. Two things that multiply to 2x squared must be 2x and x. Two things that multiply to 1 must be 1 and 1. In order to make negative 3x in the middle, we have 1x and 2x. If they're both negative, we'll have negative 3x. So we factored this. At this point, you guys know that each of these factors must be set equal to 0. If you solve for x, we find that x equals 1/2 and x equals 1. This is the same method we're going to use for these trig equations. Here we go. I'm going to teach you two methods to solve these quadratic trig equations. The first method is just going to be by factoring what you see. The second method is going to be by something called u substitution. Before we do anything, let's go ahead and move this 10 to the other side. So we're left with 6 sine squared theta minus 7 sine theta minus 10 equals 0. Let's attempt to factor this. Two things that multiply to 6 sine squared theta. We could either use 6 sine theta and 1 sine theta, or 3 sine theta with 2 sine theta. Let's go ahead and use 6 and 1. Also, we need two things that multiply to negative 10. We could either use 1 and 10 or 2 and 5. Let's go ahead and use 2 and 5. If we match the 2 up with the 6 and the 5 up with the 1 sine theta, we have 12 sine theta and 5 sine theta. 12 and 5 can easily make negative 7 if the 12 sine theta is negative and the 5 is positive. Just like with normal factoring, after this is in factored form, you can set each factor equal to 0. So we have that sine theta equals negative 5/6, or sine theta equals 2. One of these should jump right out at you. No sines can ever be bigger than 1 or negative 1. Think of the range of that sine curve. It never goes above 1 or below negative 1. Therefore, when you get a sine of 2, you know that this doesn't really yield any solutions. This one, however, does. When you see a sign that's a negative number, immediately you should be thinking that there's two answers for this. I know two places where sign is negative, in quadrant 3 and also in quadrant 4. So there's going to be two solutions that come from this half of the equation where sign is negative 5/6. After you have drawn your little pictures, you don't really have to worry about that negative sign anymore. All you have to do is focus on the 5/6 part. What angle has a sine of 5/6? Well, I don't know, and you probably don't know, but your calculator knows. Make sure you're in degree mode, and we can take the inverse sine of both sides. This is like asking your calculator, what angle has a sine of 5/6? To the nearest degree, that angle is 56 degrees. Now, in quadrant 3, we need to calculate what that 56-degree angle is, and also in quadrant 4, we need to calculate what that 56-degree angle is. In quadrant 3, it's 180 plus 56, or 236. In quadrant 4, it's 360 minus 56, or 304. You should have two answers for this equation, and we do. 236 degrees and 304 degrees. Before we move on, I want to know one thing, the calculator part. Never, ever, ever type a negative number in here in the inverse sine function. It may help you get one answer, but it's going to make it virtually impossible to get the other one. The only thing the negative tells us is what quadrants to draw this angle in. After you draw it, forget about the negative and just focus on the positive value of the trig function. I want to teach you a second method for solving this quadratic that's called U substitution. U substitution is just a way to make this thing less of a headache to look at and easier to factor. You're going to use U substitution all the way through pre-calc and calc. Here's how it goes. Let's first move 10 over to the other side just like normal. We're left with 6 sine squared theta minus 7 sine theta minus 10 equals 0. Let's go ahead and let a variable u just be sine of theta. This is a substitution game. All we're going to do is substitute in our u everywhere there is a sine theta. So here's a sine theta and here's a sine theta. If we substitute in this u, we have 6u squared minus 7u minus 10 equals 0. For some people, this thing might be a little bit easier to look at and easier to factor. We're still going to use 6 and 1, but this time it's 6u times u that gives us 6u squared. We're still going to use 2 and 5, where the 2 gets matched up with the 6u and the 5 gets matched up with 1u. 12u and 5u can make negative 7u if the 12 is negative and the 5 is positive. Again, we can go ahead and solve each of these for u after we set them equal to 0. So we see that u equals negative 5/6 and u equals 2. Now at this point, once you solve for u, you can resubstitute back in what you initially said u should stand for. We let u stand for sine theta, so we really solved this equation for sine theta to equal negative 5/6 and sine theta to equal 2. U was just a placeholder from beginning to end, so it wasn't such a disaster. Like before, you should realize that no angles have a sine of 2, but 2 angles have a sine of negative 5/6. I know 2 places where sine is negative, quadrant 3 and quadrant 4. Remember, after you draw these angles, forget about the negative thing. When you plug this into your calculator, plug it in as second sine of positive 5/6. Again, this is asking your calculator what angle has a sine of 5/6. That angle is 56 degrees. It's the 56-degree angle in quadrant 3, though, and the 56-degree angle in quadrant 4. In quadrant 3, that's 180 plus 56, or 236. In quadrant 4, that's 360 minus 56, or 304. The same 2 answers with U substitution, 236 and 304. Pause the video and try the example below.